Okay, so we are still dealing with infinity minus infinity. We are going to do 2 more examples here where we have to combine our infinity. So we have to do a little bit of a different thing than we did in the last one. So let's just get straight into it. So our example here, the first one we're going to do, oops, I don't like that color together. So is the limit as x goes to pi over 2 from the left of secant x minus tangent x. So we need to plug in. So that means I need to think about what is secant of pi over 2 from the left. And a good way to do this is to think of this as 1 over cosine of pi over 2 from the left. But I know that 1 over cosine of pi over 2 is 0. So this is going to give me infinity, but is it positive infinity or negative infinity? That question is actually really, really, really important to answer right now, because remember that signs matter with infinity minus infinity. Infinity minus infinity, indeterminate form. Infinity plus infinity, infinity, no problems. So we're just going to draw a little graph of cosine here. So cosine x looks something like that. So if I'm on the left side of pi over 2 here, the left side of pi over 2, as I get closer and closer to 0, my values there are positive. So this is like 1 over 0 from the right, which means that this is a positive infinity. That sign is super important. So this is positive infinity minus. For tangent, it's also going to be super important. So I'm looking at tangent of pi over 2 from the left, oops, from the left. So here it's also going to be useful to look at our graph of tangent. So we saw the graph of arctangent earlier. Hopefully you remember what the graph of tangent looks like, but if not, we're going to draw it here to sort of help you. So I have these asymptotes at pi over 2 for tangent, and I have my function kind of repeating itself over and over and over again. So I'm like 2, 2, 2. So when I'm on the left side of pi over 2, I'm right here, and I can see that this is on its way up to positive infinity. So this is positive infinity minus positive infinity. So that does indeed give me the indeterminate form. So this tangent right here is going to positive infinity. Now, alternatively, I could have thought of this as sine of pi over 2 from the left over cosine of pi over 2 from the left, which would have given me 1 divided by, again, that 0 from the right. And we could have also seen like that this is going to positive infinity. Note that tangent of pi over 2 from the right would have been negative infinity. And we can see that right here. We can see that tangent going down. Oh, that is not a good color combo. It's kind of hard to see. We can see that that tangent is on its way down there to negative infinity. We're on the right side of pi over 2. Okay, so what we've seen so far is that we could just factor something out. But because this is trig, using our trig identities to rewrite this and trying to find a common denominator is going to be a really good way to approach this problem. So here we will have the limit as x approaches pi over 2 from the left. I know that secant x is 1 over cosine x, and tangent x is sine x over cosine x. So this gives me the limit as x approaches pi over 2 from the left of 1 minus sine x over cosine x, which is now a much simpler way than factoring of getting this to a form where now we have 1 minus 0. I'm sorry, by 1 minus 0, I mean 1 minus 1 over 0. That is 0 over 0. I am now allowed to use L'Hopital's rule. I have my form, my indeterminate form that allows me to apply L'Hopital's rule. So let's do it. We'll get the limit as x approaches pi over 2 from the left. The derivative of sine is positive cosine. So we end up with a negative cosine up here. And the derivative of cosine x is sine, negative sine x. So I'll have a negative sine x down here. Oops. So we have negative sine x down here. Those negatives cancel each other out. And then when I plug in, this is cosine of pi over 2 is 0 and sine of pi over 2 is 1. And 0 over 1 is just 0. So my final answer here is 0. Okay, so on to the next video for the log rules.